In this session, we're going to talk about Math Quiz 1 preparations to prepare you guys for your upcoming quiz. Now, we've combined the selected questions from 2021 to 2024 from Quiz 1 papers. Okay, let's begin. So, our first question is x squared plus 4x plus 5 is equals to 0. Give your solution in the form a plus ib, where a and b are real numbers. So you know a plus ib, those are just complex numbers. So in this case, we're going to use quadratic formula, because we've been given a quadratic equation. So you know from your quadratic formula, we say x is equals to negative b positive or minus the square root of b squared minus 4ac. The whole expression is divided by 2a. Now, in our case, our a will be equals to what? In our case, our a will be equals to 1, our b will be equals to 4, and our c will be equals to 5. Okay, now let's solve. So say x is equals to, our b will say that it's going to be 4, so that will be negative 4 positive or minus the square root of our b will say it is 4, so b squared minus 4, our a is 1, our c is 5. Okay, everything over 2, our a is 1. Okay, so x will be equals to negative 4 positive or minus the square root of 4 squared, that is just 16, minus 4 multiplied by 1 multiplied by 5, that is a 20. So we have a 20 divided by our 2 multiplied by 1, that is just 2. Okay, so now what do we have? So this will just be simplified to you know, you have negative 4 positive or minus 16 minus 20, that is negative 4. So we have a negative 4 over 2. Okay, let's simplify this expression now that we have on this side. Okay, so what are we going to have? We'll say negative 4 positive or minus the square root of everything over 2. Now we're saying the square root of negative 4. This can also be written as, we're saying the square root of negative 4. This can also be written as, you know, the square root of negative 1 multiplied by 4. Okay, which will be simplified as the square root of negative 1 multiplied by the square root of 4. And you know, the square root of negative 1 the square root of negative 1 is just equals to I. Remember, your I squared was equals to negative your I squared was equals to negative 1. So what do you do? You do your square root on both sides. So your I in this case will just be equals to the square root of negative 1, which is a complex number. So even in our case in this side, so where is the square root of negative 1 will have I. Then the square root of 4, that is just a 2. So we'll just have 2i. Okay, so let's wrap this expression. So we'll wrap here and we'll just put our 2i there. Okay, so this is our expression. So what will be our answer now? Okay, so our answer in this case will be, we'll separate this. It will be negative 4 over 2. Let's say positive or minus 2 over 2 I, like that. Okay, when we divide, what are we going to get? We're going to get negative 2 positive or minus I, because this and this will just give us 1. So our solutions, the first one would be negative 2 plus I. The second one will be negative 2 minus I. You've expressed it in the form a plus ib. Let's solve another question. We're taught to define a complex number. Now you must know how to define all the the sets of numbers, such as natural numbers, what are real numbers, what are rational numbers, what are irrational numbers. So you have to know all those definitions. So complex numbers are just numbers that have the real part and the imaginary part. Remember when we used to draw our complex numbers, we said we said if this is the y-axis and this is the x-axis, in this case, if you are showing your complex number, this will be your real part. In this case, this will be your a. Okay, this is our x and this is our y. Okay, then this will be the image of a. Let's say in this case ib, like that. Okay, so that's what we're talking about. It's like just the image of a and b. Remember transformation. So that's about a complex number. It has a real part and an imaginary part, and these are the biggest numbers that we can talk about in terms of expression. Let's solve number 2. Express the following numbers in the form a over b. B is not 0 and a, b are integers. Okay, these are rational numbers. Rational numbers are those numbers that can be expressed in the form a over b, where a and b, these ones are members of integers, and your b should not be equals to 0. Why? Because you don't want to have a situation where you have a 0 here, because 0 make the fraction undefined, and that's what you don't want. Okay, so these are rational numbers. So examples of rational numbers, I'm sure you remember, if you've got 1 over 2, this will just give us 0.5. Now you can put 0 here, and 0 just means that it's repeating like that. So it's the same as these expressions that we're given here. Okay, so let's solve the first one. Okay, for the first one we have that. So what we are going to do, we're going to we choose any letter. Let x is equals to 0.4834, repeating. Okay, now what I'm going to do, you want to make sure that the point moves from where it is. It moves 1, 2, 3, close to where the repeating decimal starts from. Okay, so let's just do that. So what are we going to get? Okay, what are we going to get? So we're going to multiply the top by 1000. Okay, now we are multiplying both sides. Okay, okay, so what we have, okay, so we just have 1000x on the other side, then on our right side we have 483.4, repeating like that. Okay, now that we've moved a step further, what are we going to do? We're going to multiply by 10 again on both sides. Okay, so now what are we going to have? We're going to have on this side, we're going to have 10,000x. This will be equals to, when the point moves to the other side, you have 483.4, repeating like that. Okay, so now when we do the math, so what are we going to do? Let's name this one as let's say this one is equation 1, this is equation 2. Okay, so what we're going to do is we're going to do equation 2 minus equation 1. Okay, so we're doing 10,000x minus 1000x. So what do we have? That is just 9,000x. Then on the other side, we're going to do this minus that. Okay, so let's try. What are we going to have? Okay, 4834. Okay, I'm getting 4351. Then for it to remain with your x, what are you going to do? You're going to divide by 9000 on both sides. So therefore your x will just be equals to 4351 over 9000. Then if you can simplify this further, just look for two numbers that you can divide to give you to express it to its lowest form. Okay, now let's solve the next one. So you can complete that one. It has been expressed as a fraction, and make sure that they don't have a common factor like that. Okay, now let's solve the second one. Okay, so again we're going to let let's say we choose any letter. Let x is equals to 7.23. okay, now you notice that this one has two repeating numbers. So what are we going to do? We're going to multiply this expression by 100 on both sides. Okay, so what are we going to have? We're going on the left, we're going to have 100x. Our 100x in this case will be equals to, when the point moves 1 2, so we have 723.23 repeating. Okay, so now what are we going to do? Let's name this one as equation 1. Let's name this one as equation 2. So we're going to do equation 2 minus equation 1. Okay, so what are we going to have? So if you say 100x minus x, what are we going to have? That will just give us 99x is equals to, when we do 723 minus 7, okay, what are we going to have? 723 minus 7, that is just giving me 716. okay, we're going to divide by 99 on both sides. Okay, so our x in this case will have 716 over 99. Then you should try if you can find a common factor that can go in both 716 and 99. If there is no, then that's where you end from. This is just the same as the one 7.23. yeah, so like that. So you've expressed it in that form, a over b. Let's do another question. We're trying to simplify this expression. So what are we going to have? So let's say the square root of 2 plus 1. Okay, this is multiplying by square root of 2 plus 1. Okay, so these are surds. So what are we going to do? This is going to multiply by the whole expression. Then what are we now going to do again? Again, your 1 will multiply by everything in this expression. Okay, so let's just do that. Okay, so let's start with 2. Okay, when 2 multiplies with everything, so we have 2 multiplying by 3 root 2 plus 1. Then now we have 1. So our 1 is plus positive 1. This is multiplying by this is 3 root 2. Okay, plus 1 like that. Okay, so let's multiply. So 2 will multiply by this expression. So what are you going to have? So you have 2 like that. Okay, you know that root 2 multiplied by root 2 it's just the same as root 2 squared, and your root and your square cancel, so you just remain with 2. So that's what we are doing there. Okay, so let's just do that. That's why we've written 2. Okay, then this you are saying now on the other side, what are we now going to have on the other side? Is now this root 2 multiplied by your 1 there. So what are we going to have? We just have positive root 2. Okay, let's come the other side. When we multiply 1 by everything in the bracket, it just remains the way it is. So we just have 3 root 2 plus plus 1. Okay, so now what are we going to now have? If we multiply 2 multiplied by 3, that is a 6. Okay, and if you add our 6 plus this 1 this side, just give us 7. Okay, so let's just write that. So we have 7 plus root 2 plus 3 root 2. Now, can I ask a question? Are these like terms? This one and this one. Okay, let's say you have x plus 3x. Are these like terms? Yes, they'll add. So we just have 4x. So even in this case, we're going to add these ones. So our final answer in this case will be, we have 7 plus, when you add the, root 2 plus 3 root 2, that will just give us 4 root 2. Okay, let's go to another question. Okay, if z1 is equals to 1 minus I and z2 is equals to negative 1 plus I root 3, we have to show that that expression is equals to that expression. We also have to show that z bar multiplied by z is equals to the modulus of z 1 squared. Okay, let's solve the second one. We'll not solve the other one because of time. So what are we going to now do? We're saying you have to remember that z in this case is just your actual complex, your complex number. If you've got a plus ib, this is just your z. But if you say z bar in this case, we're talking about the conjugate of this. So the conjugate of this will just be a minus ib. Okay, you must know that. Then never make a mistake. If you've got let me say your z in this case, let me say if it's negative 1 plus I, maybe let me say 5. So never make a mistake when you're doing your conjugate. Don't also change this one. This one is just a constant like that. Then it's just the imaginary that will change. Okay, so those are some of the tricky parts that you'll find. Okay, don't make that mistake. Okay, then the other thing that I can talk about on this one before we start solving is you finding the modulus. Okay, so the modulus in this case, we're saying the modulus of z. Okay, so the modulus of z in this case will be, you're saying it's just the same as x, x squared plus y squared. That's what we're talking about. Then the square root of these ones. So that's what we're talking about. So in this case, if let's say this is 2 plus I3. So in this case, our z modulus will be 2 squared plus 3 squared, like that. Okay, so that's what we're talking about. Then you solve and you find the answer. So even in this case, in our one this side, that's what we're going to do. Okay, so let's solve the second one. Okay, let's solve the second one. Okay, so we've got z. This is multiplying by, this is z1 and this is z1. This should be equals to the modulus of z, squared 1. Okay, our z bar in this case is a conjugate of z. And what is z? What is z1? Our z1 is 1 minus, it's 1 minus I. This is our z1. So it means our z bar in this case, our z bar 1 is, it will just be 1 plus I. Okay, so we're just multiplying. This is 1 minus I. This is multiplied by 1 plus I, like that. Okay, then on the other hand, we're saying z1 squared. Okay, so in this case we just have the square root of, let's say x squared plus y squared. But now this is, there's a square here, so you put your square outside like that. Okay, so what are we going to have? we've said our z1, so this is our 1 and this is our I. So these are the ones we're placing on x and y. Okay, so let's solve. So this is the difference of two squares. Okay, so what are we going to have? So the difference of two squares, this will just be the same as 1 squared minus I squared on this side. So then on the other side we have we've said the square root of our x in this case we've said is 1. So this is 1 squared minus I squared. Okay, then this, you remember there's a square root here. Okay, so what do? You put your square root down out there. So 1 squared is just 1. Negative I squared, this will just give you positive 1. Okay, then on the other side, you know, your square root and the root will cancel, so you just have 1 minus I squared. 1 squared is 1 and 1 negative I squared, that is just positive 1. Okay, so what are we going to have? 2 is equals to 2. So you've shown them that that's how you solve that one. Okay, so now let's then let me just give you a clue on the second one, how you solve the second one. So the first one actually, so for the first one, what you're supposed to do is they've given us our z1, which is that, and our z2 is equals to that. Then want to show that z1 multiplied by z2 should be equals to, this is the bar, okay, multiplied by z1 which is multiplied by z2, and it's just like that. So what are you going to do? So what you're going to do is first find what z1 and z2 are. When you find that, then now you find the conjugate of the answer. That's what we're talking about on this side. Then on the other side, you just do the same, but this one you're just multiplying the conjugate of z1 and the conjugate of z2 like that. Okay, then you compare on the other side. So that's the same expression that we're talking about. Okay, let's proceed. This one is on on simplifying sets. Okay, so we've got x squared, or x, there's a complement union, we've got y intersection z. Okay, these ones are in big brackets. Okay, you've got your I there. So now this is just De Morgan's law, where you say if you've got A intersection B, okay, then there's a complement outside, you distribute the complement on A, on the symbol, and also on B. Okay, so what do you have? So what you just have on the other side will just be, you just have A complement, the intersection will change to union, then B will be like that. Then the opposite is also true. If you have got A union B, okay, you do that, you have A complement intersection B complement. So that is the De Morgan's law. So you have to know this law for you to solve this question. Okay, so let's start. So let's first distribute the complement. So this complement will distribute on the first set, which is x complement, then it also distributes on this set y intersection z, like that. So let's just do that. What are we going to have? So on the first one, you find that the complement and the complement will cancel, so just remain with x. Then the symbol in the middle changes to intersection. Okay, then when it falls on this side, it is y intersection z complement, like that. Okay, let's solve the second set. So x intersection, so when you distribute the complement, it will go on and the y, the operation and the z, like that. Okay, let's just do that. Okay, so what are we going to have? We have y complement union z complement, like that. Okay, So now we're trying to find the intersection of x and y complement union z. Now if we were to draw y union z, let's say this is our Venn diagram, okay, not really drawn to scale. So let's say this is our y and this is our z, and let's put a different color. Let's say this is our y and this is our z. Now we are trying to find the y complement. Now let me denote y complement as our white, like that. Everything that is not in y, everything that is not in y will be that. Okay, now let's also find the z complement. Now z complement will be everything that is not in z. I'll indicate by blue. Everything that is not in z. So at the end of the day, you realize that everything is shaded, and everything that is shaded, this will just be equals to our universal set. Okay, so our answer in this case, let's continue. So we have x intersection, this is just, we said this is the universal set. Now what is common between x and the universal set? Okay, so if this is the universal set, x will just be a subset of the universal set. So our answer in this case, what is common, will just be x, like that. Okay, now let's solve the next one. Okay, so the next one we have okay, so the next one we have we've got y intersection x intersection y. Okay, so okay, this will be the same expression. So I think the best way to illustrate this one is when we draw as well. So if we were to draw for this one, what are we going to have? We'll have, let's say this is our x and this is our y and this is our x. Okay, let's say this is our y and this is our x. Okay, now x intersection y in this case will just be this part. We know that. Okay, but now we're also trying to find that. Then what is y? Y in this case, let me denote y by y is this part. Okay, y also include the same intersection. So now what is common between y and the x intersection y? You realize that it is this part that I'll put in blue, like that, the same one. Now what is this part? You realize that this part is just x intersection y. So in this case our answer will just be x intersection y, like that. Okay, so let's solve another question. Okay, we're taught to express in the simplest form the number 1 pointer that is 1.115 repeating in the form of p over q, where p and q are members of integers. So what are we going to do? The way we're solving rational numbers, let x is equals to 1.115 repeating. Okay, what are we going to have? Your goal for you is for this point to move 1, 2, so that it is very close to where the repeating number is. Okay, so let's just do that. So what are we going to multiply by? We're going to multiply this expression by 100, right, on both sides. Okay, so let's just do that. So when we do on the left side, what are we going to have? On the left side we'll have 100x actually. Then when we do on the other side, we're saying it's moving 2 times, so it will 1 1 okay, 1 1 1. This is 0.5 repeating. Okay, now that we've reached our target, we've moved 2 steps. Now what are we going to do? Again, I want to move the point 1 step this side. So let's just do that. So what are we going to do? Again, we're going to now this time we're going to multiply by a 10. Okay, on both on both sides. Okay, let's just do that. So now what are we going to have on this other side? We're going to have 1000x is equals to okay, you have okay, you have 5.5 repeating like that. Okay, so now what do we have? So now what are we going to do? Let's name this this one as equation 1, this one as equation 2. So like we earlier did in our previous question, so just say 2 minus 1. Okay, so let's just do that. So in this case it will be 1000 minus 100. So if you're doing 1000, you know, minus your 100, in that case you just get 900. So you have 900x should be equals to, when you subtract this 1115 minus 111 like that, so what are you going to have? Okay, I'm getting something like 1004. Okay, so now you're going to divide by 900 on both sides so that you remain with your x. So your x in this case, let me just write it on top. Your x in this case will be, if there's no number that can go in between these numbers, so you have to find out if there's a number that can go in both sides. But if there is not, then you're done. This has been expressed as a fraction p over q. Okay, they should not have a common factor like that. Okay, let's solve another question. Okay, we're taught to express the following in terms of the simplest surd. Okay, so the first one that we have is 500, or the root of 500. This is plus the square root, this is 5. So we have 5 root 20 minus root 45. Okay, so what are we going to have? If we say, so we're going to look for two numbers that we can multiply, they'll give us 500, but at least one should have a perfect square or a square like that. Okay, so let's choose 100 multiplied by 5. That's the closest one. 100 multiplied by 5. Okay, if this one doesn't work, we'll try again. Plus, we have 5. For 20 again, let's say we can choose, let's say 4 multiplied by 5. Okay, 4 multiplied by 5 minus, for 45, which two numbers? We can say 9 multiplied by 5. Okay, so now let's solve. You know, the square root of 10 is just the square root of 10 multiplied by the square root of 5. That's what that expression is. Plus, even this expression is the square root of 4 multiplied by the square root of 5. Okay, minus, this will be the square root of 9 multiplied by the square root of 5, like that. Okay, so let's simplify. The square root of 100 is what? The square root of 100 is just the square root of 100 is just 10. Okay, this is multiplied by root 5. Okay, plus we have then the square root of 4 in this case is 2. Then 2 multiplied by 5, it will give us a 10 here. So we have 10 root this 5. Okay, then we have minus. Now the square root of 9, that is 3. Root 5 remains like that. Okay, so these ones have got the same variable like that. In this case is root 5. So what are we going to do? We're just going to simplify. So our final answer in this case, if we say 10 plus 10, that is 20. 20 minus 3, that is 17. So we have 17 root 5 like that. Okay, so that's how we'll solve this one. Okay, we solved a lot of surds. Then there's the second one, which is okay, let's also solve the second one. Okay, let's solve the second one. Okay, so how are we going to solve the second one? We are saying the square root of 27 over 6. Okay, this is like that. Okay, let me just write it nicely. So okay, so we are saying we have the square root of 27 over 6. So what are we going to have? This is just the same. You remember the rule, if you watch one of our videos, it's 1 over maybe a over b. So this will just be the same as the square root of a over the square root of b. So that's how we're also going to do this. So what are we going to have? We're saying we're going to have okay, saying this is 6, so we're going to have this, it will be equals to the square root of 27 over the square root of 6. Okay, so let's proceed. Two numbers that we can multiply to give us 27, and one at least should have we should be able to find the square root for that. Let's say 3 multiplied by 9. Okay, over two numbers that we can multiply. Let's say, okay, let's also simplify this one. We say 3 multiplied by 2. Okay, so what are we going to have? On top, the square root of 9 in this case will just be 3. So we have 3 root 2 on top. Okay, through 3 root 3 actually. Okay, 3 root 3. Okay, so let's wrap this 2 like that. Okay, so this is 3 root 3 like that. Then down here we've got 3, you know, the root of, or 3 multiplied by the root of 2. So what can we do? This root 3 and root 3 can cancel. Is it? Yes, they can cancel. So on top we just have 3 over, to be 3 over root 2. Now, you remember for Surds, if you leave it like this, probably they might give you a mark if they're very lenient. But for Surds, always make sure that you rationalize the denominator. Okay, like this question. So we're not going to solve this question because even just see. So you're just going to rationalize the denominator. So what are you going to have? Or you just want to remove the root. So what are you going to have to remove the root? So you're going to multiply by root 2, both on the denominator on the, you know, the numerator. Okay, so what are we now going to have if we do that? So if we do that, we're going to have an expression like on top, if we multiply 3 multiplied by root 2, that is just 3 root 2. Okay, down, you know, root 2 and root 2, we say if you've got a, this root a multiplied by root a is just the same as a, you know, this squared, and the root and the, you know, the square root and the root will cancel, just remain with a. So even in this case, root 2 multiplied by root 2 will just give us root 2 multiplied by root 2 will just give us 2. So therefore, finally, our answer in this case will be 3 root 2 this over 2. Now we don't have a root downward, so which is even better. So this will be your final solution. Okay, let's look for another question. Okay, so we are told to express the following in terms of the simplest surd. Okay, we have the square root of 7(2) minus 8 root 3 plus 3, you know, root 48. Okay, so what are we going to have? Let's say the square root of, you know, let's look for two numbers that we can multiply. They'll give us 72. 2 into 72, that will give us, let's say, 3 into, okay, 2 into 12, that is like 6. Okay, 3, 36. Okay, 3 multiplied by 36. I think that can also work. No, 3 into, that is 2. Okay, 3 multiplied by 24. Okay, can work. Okay, can we, is 24? Okay, we'll still break 24. Okay, minus, let's say 8. This is 8 root 3 plus 3. Now the square root of, let's say 48. Which two numbers? Let's say 2 into 48, that is 26. No, that is 20, like 24. No. Let's say 3 multiplied by 16. Okay, 3 multiplied by 16. Yes, that one also work. So what are we now going to have? So we'll say 3, or the root of 3 multiplied by, let's break down the 24. Two numbers, there is 8 and 3. Okay, let's go for 6 and 4 give us 24. Then on the other side, what are we going to have? Negative 8 root 3 will just remain the way it is, plus 3. Okay, on this side there's 3 and times times 16. So what are we now going to have? In this case we're going to, okay, let's just simplify this one. Okay, let's just simplify this part. Okay, so what are we going to have? The square root of 16, that is 4. This 4 multiplied by our 3 there, so we have 12 root 3, like that. Okay, hope this resonates. Okay, then let's also do now this part. We have the square root of 4, that is just a 2, right? Okay, that will just be a 2. Okay, so this will be 2 root 3 multiplied by root 6, right? Then on the other side, what are we going to have? Okay, these have the common negative 8 and 12, they've got a common variable. Let me just put x like that. So we'll just use basic arithmetic to solve them. Okay, so what are we now going to have? Negative 8 plus 12, that will just give us positive 4. Then we have a root 3, like that. Okay, now is there anything that we can do from now? Okay, is there anything that we can do from now? Okay, it seems like we have root 3 on both sides. There's root 3 here and root 3 on the other side. Okay, let's just try to factorize that so that our final answer now will be, if we factorize that part, we have root 3 is equals to 2 root 6 plus 4, like that. So this will be your final answer when you factorize the root 3 that is on both sides. Okay, there is another one there. Okay, let's also solve okay, that is okay, another different kind of rationalizing. Okay, let's solve the other one. Okay, let's solve that one as well. Let's just rub here. Okay, so let's solve that. So we've got 1 minus root 2 over 1 minus root that root 8. Okay, root 8. So what are we going to do? We're going to multiply by the conjugate. The conjugate, right? Yes, so the conjugate in this case is just 1 plus the root of 8 on both sides, on both the denominator and the numerator. Okay, let's just do that. Okay, so down we just have the difference of two squares, which is 1 squared minus root 8 squared, like that. Okay, good. What now are we going to have on top? So this will multiply by that. Okay, let's just do that quickly. So our 1 multiplied by everything, it will just be that thing, everything. So 1 minus root 8. Okay, then our root 2, our negative root 2 multiplied by everything in the brackets. So you have negative root 2. This again negative 2 multiplied by your positive 8 on this side. Will have let's say you have negative root 2. This is multiplying by root 8, like that. Okay, so now let's solve. So what are we going to have? we have 1 plus the root of 8. The root of 8 we can also write it as that is 2 multiplied by 4, right? Okay, so now that is, it will just be the square root of 4, that will be 2, so 2 root 2. So this is just the same as, okay, let's just write it here. So the square root of 8 will just be, we're saying it will just be 2 root 2. We're saying minus root 2. Then here again we're just going to do the same as well. So this is minus 2, this is multiplying by 2 root 2. Down, what are we going to have down? Now down we're going to have 1 squared. 1 squared is just 1. Then 8, the root of shan, so 8 and the root will cancel. The squared and the root will cancel, so you just have 8 like that. 1 minus 8, that is negative 7 down. Okay, so let's solve on top, and let's also check what we have now. Okay, so let's rub on top just for okay. So what do we have on top? We've got 1 plus 2 root 2 minus root 2 minus root 2. We multiply this by 2 root 2, okay, over, I think over negative 7. Okay, so what are we going to have? Are there any like terms? Okay, we've got first we have to multiply these ones. Okay, so what are we going to have? So we have 1 plus 2 root 2 minus root 2. When we multiply root 2 multiplied by root 2, that will just give us 2, right? 2. Okay, 2. So this will have minus 2 root 2 there. Okay, so what are we going to have? Negative 7 down. So when we do this, what are we, is there any common thing? Okay, so we've got positive root 2 and negative root 2. Okay, so these ones will cancel. So these ones will cancel. This one and this one will just cancel. When you add them, they just give you. So you have 1 on top. We've got 1 over 1 minus root 2. This is over negative 7. Now, how do you now completely show this one? So how you completely show that one? It will be 1 over negative 7. Okay, minus, or let me say plus. Okay, let me say just okay, plus root 2 over 7, like that. Okay, so you're done with this one. Okay, is there any other question that we can solve? Okay, let's solve the last one. Expressing the simplest form, the number negative 0.255 in the form p over y. Okay, so we're going to use the same analogy that we've been using. So you say let x be equals to that expression, negative 0.255. Now 5 and 5, these ones are repeating. Okay, so what are we going to have? Okay, so like in the previous cases that we've been doing, so we're going to multiply on both sides by, you want the point to move where it's close to the repeating number. So let's just do that. So we're going to multiply by, for it to move to that point, it will multiply by 10, right? By 10. Okay, so let's do that. So we have 10x on this side is equals to, when the point moves of 0.2.55 repeating. Now again we're going to multiply this equation by, we want now the point to move 2 times. So we're going to multiply by 100. Okay, on both sides. So this will be 1000x will be equals to negative 0.5. This is repeating. Okay, so now what do we do? Let's call this one as equation 1. Let's call this one as equation 2. Okay, so what are we going to do? We're going to do equation 2 minus equation 1. Okay, so what do we do? So we say 1000x minus 10x. So we're saying 1000x minus 10x. So you have 990x is equals to, now when you do 0, let me just say okay, negative 2. Okay, that is just negative 0 to 55, you know. Okay, that is 0 to, okay, yep. So I'm getting something like you know, I'm getting something like negative 253, like that. Okay, so you're going to divide by 990 on both sides. So your x will just be equals to this when you simplify it, if there is any number that can go in both of them. But if there's nothing, then you end there. So this is where we end from today. Thank you for reaching up to the end, and don't forget to subscribe to our channel. See you in our next sessions.